there ever be no more prime numbers? This is the question of the century that has shaken all of humanity. No, there will never be no more prime numbers. This is a fundamental result in number theory, proven by the ancient Greek mathematician Euclid over 2,000 years ago. His elegant proof demonstrates that there are infinitely many prime numbers. Here's a simplified explanation of Euclid's proof. 1. Assume a finite number of primes. Let's imagine, for a moment, that there is a finite list of all prime numbers, p underscore 1, p underscore 2, p underscore 3, l dots, p underscore n. 2. Construct a new number. Consider the number n formed by multiplying all these primes together and adding 1. N equals p underscore 1 times p underscore 2 times p underscore 3 times c dots times p underscore n plus 1. 3. Analyze the new number. Now, let's think about the prime factors of n if n itself is a prime number. Then we have found a prime number that is not on our original list. Since n is larger than all p underscore 1, p underscore 2, l dots, p underscore n. This contradicts our initial assumption that we had a complete list of all primes. If n is not a prime number, then it must be divisible by at least one prime number. Let's call this prime factor page. Could this prime factor p be one of the primes in our original finite list? P underscore 1, p underscore 2, l dots, p underscore n. If p were in our list, then p would divide the product, p underscore 1 times p underscore 2 times p underscore 3 times c dots times p underscore. If p divides both, p underscore 1 times p underscore 2 times p underscore 3 times c dots times p underscore n, and n equals p underscore 1 times p underscore 2 times p underscore 3 times c dots times p underscore n plus 1. Then p must also divide their difference, n, p underscore 1 times p underscore 2 times p underscore 3 times c dots times p underscore n equals 1. However, no prime number, by definition, a prime number is greater than 1, can divide 1. This leads to a contradiction. 4. Conclusion. Therefore, the prime factor p of n must be a prime number that was not in our original finite list. This means that our initial assumption of a finite number of primes must be false. Thus, there must be infinitely many prime numbers. In simpler terms, no matter how many prime numbers you find, you can always use this method to show that there must be at least one more prime number that you haven't found yet. This process can continue indefinitely, implying that the sequence of prime numbers never ends. While prime numbers become less frequent as numbers get larger, a concept described by the prime number theorem, they never cease to exist. There will always be larger prime numbers waiting to be discovered. If you want to learn